Welcome to Premath. In this video tutorial, we are going to calculate the area of the circle that is inscribed in this square, as you can see in this figure. And moreover, we have this red rectangle that is also inside this square. The length of this red rectangle is 2 and the width is 1. And we want to calculate the area of this circle. So in order to calculate the area, we need to find the radius of this circle first. So let's go ahead and get started with our solution. And here's the very first step. Let's remove the shade from this figure. And here's our figure without shade. And now we are going to draw a diameter that passes through this center. So I'm gonna draw this diameter right up here. Just bear with me. This point is an A and this point is a B, and this is our diameter AB. And here's our much nicer looking diagram with AB as our diameter that passes through this center O. Then according to the tangent to a circle theorem, and here's the definition of a tangent to a circle theorem: the angle between a tangent and a diameter is 90 degrees. That means they are perpendicular. So that means that this diameter AB is perpendicular to this horizontal side of this square, which is also a tangent. And here is our next step. Let's consider this diameter AB as a line of reflection. Then we will see the image of this rectangle on the other side, as you can see over here. Then as we can see, the dimension of this image rectangle is also going to be 2 and 1. Now let's go ahead and connect these points C and D really carefully. And here's our much nicer looking diagram. And moreover, this chord CD intersects this diameter AB at point E, and they are perpendicular as well. And in this next step, we are going to draw the radius OF. That is going to be somewhere here, the radius of this circle, and I'm going to call this point F. So then, according to a tangent to a circle theorem, this radius OF is perpendicular to this tangent. Now let me go ahead and call this radius R over here. Then this radius is also going to be ROB, and this OA is going to be R as well. And moreover, the length of this rectangle, this is 2, and this is 2 on this side as well, and the width of this rectangle is 1, so this is going to be a 1 as well, and this is going to be 1. And also we can see that this radius OF is R, so that means this length is going to be R as well. Then the length of this side is going to be R minus 2. So I'm going to call this one R minus 2. Then this side is going to be R minus 2 as well. And we know that the diameter AB of this circle is going to be 2R, isn't it? This is 2R. So the length of this part is going to be a EB is going to be a simply 2R minus this part, okay, minus 1. And now let's focus on the diameter AB and this chord CD, and they are intersecting each other at point E. Then we are going to apply the intersecting chords theorem. And here is our intersecting chords theorem. A times B equal to C times D. And here, as you can see in this circle, we have these two chords, and this is part A and this is part B of the first chord, and this is part C and this is part D of the second chord. And we are going to apply the same analogy in our example. And here you can see that our A is going to be R minus 2, and our B is going to be R minus 2 as well, and our C is going to be 1, and our D is going to be a 2R minus 1. And now let's go ahead and apply the chords theorem to this our problem. So A in our case is R minus 2 times B again is R minus 2 equal to, in our case, C is 1 times D in our case is 2R minus 1. Now let's go ahead and multiply these R minus 2 and R minus 2. We are going to use the FOIL method. That means a double distribution, that is going to give us R square minus 2R minus 2R plus 4. And on the right hand side is going to be a 2R minus 1. So on the left hand side, this, when we simplify, become R square minus 4R plus 4. And when we move this 2R and negative 1 on the left hand side becomes negative 2R plus 1 equals to 0. And let's simplify furthermore. We got R square minus 6R plus 5 equal to 0. And here we got a quadratic equation. Let's go ahead and factor that one out. Our possible factor is going to be R minus 1 times R minus 5 equal to 0. And now let's separate them. We are going to get R minus 1 equal to 0 or R minus 5 equal to 0. That means we have a R equal to 1 or R equals to positive 5. Now as you can see, R equals to 1. If we apply over here, then R minus 2 is going to become negative 1, and we know the length of a side cannot be negative number, so that means we are going to discard this solution. So therefore we are going to accept R equal to positive 5 as a solution. So thus the radius of this circle turns out to be R equals to 5. And here is our final step. Let's recall the area of a circle formula. And here's the area of a circle formula. A equals to pi R square. And we know R in our case is 5. Let's go ahead and fill in the blanks. So area equal to pi times 5 square. So that means A turns out to be a 25 pi. And we know the value of pi is 3.14. So area could be written as 25 times 3.14. And if we multiply that one out, so we get 78.5. So thus the area of this circle turns out to be 25 pi, or in terms of decimals, area is going to be approximately equal to 78.5 square units. And that is our final answer. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.